Okay, we're doing a little bit of review for the cumulative number 6. Right this minute, kids have been asking me about graphing questions, and I've taken an example one here. This is not on your review worksheet, but generally this is the general look of a log graph, and then it's been moved to the left and down, so it looks something like that. And we were going to try some points. Do you get that it would be really nice if that right there was an E? Because then I'd have log base E of E minus 2. And if those two match up, then what's that equal to? 1. This part right here would be equal to 1. And then I go 1 minus 2 would be negative 1. So how can I make this equal E? How can I make this right here equal E? Well, I actually write, like, did they have you write it out? X plus 4 needs to equal E. And then you can solve it. So then I need to go, okay, well then, I have to subtract 4. X will have to equal E minus 4. Okay. What is E again? 2.7. If I go 2.7 minus 4, that's going to be negative 2.3, I believe. 2.7 minus 4, am I right on that? Negative 2.3? I think you might be right. Negative 1.3, let me check that. You're right, thank you for catching me on that. It's a really easy mistake to make. Okay, so I want to put in x is negative 1.3. Why? Because then when I put in negative 1.3 here, that turns out to be 2.7, which means this and this match up, which means I'll have 1, and then I take the minus 2 away from it. 1 minus 2 is negative 1. There's one of the points that's on my graph. Negative 1.3, negative 1. It seems plausible that could be on that green graph there. So that's one example. Another would be if you won the argument, you get nothing. And that's a nice thing to get. So if I could make this whole thing here equal 1, that would be nice. So you say, I want to let x plus 4 equal 1. Subtract 4 from both sides. X will equal 1 minus 4, which would be negative 3. So I should put in negative 3 and see what happens. When I put in the negative 3 right here, negative 3 plus 4 makes 1. And then log base E of 1 is the same as 0. And 0 minus 2 is going to be negative 2. There's 2 points on my graph. So the painful part about graphing is to find exact points. You need to find the argument, in the case of a log, and make it equal the base, and make it equal 1. If you're doing an exponential, let's say I had that one. Then I want, it's much easier, but generally speaking, I want the exponent to be 1 or 0. So I either set x plus 3, I want it to equal 1, and I solve that, or x plus 3, and I want it to equal 0. Because 0 exponents and 1 exponents are very easy. So negative 2 and negative 3 are the two things I've put in my XY chart. And I'd find out what they are by sticking them in. Okay, that's the general idea for graphing. Now, of course, if you're stuck on an individual during work time, I'll be glad to have you come up and ask me. Okay, let's flip to the next page. I'll be done soon here, because usually these are pretty fresh in your mind. These are ones you've just done on the last test. Yes, sir. This cumulative packet is different because it is an optional cumulative test. This packet is less important to me than the packet you're going to be doing for the final. It is something I want you to do. Whether or not I collect it, I am still debating. And I guarantee you I would not be requiring you to do every problem in it. My ideal student here would have the time and do all of it. My second best scenario is you're too busy, you don't have time, but you go through and do some that you know you could practice for you. I can't think of a single student where I would say, don't do any of it, you don't need to, because we all need to brush up a little bit before the final. Even the log master. All right. Are there any others that you want to ask about on that last page? Be happy to do at least one. I mean, I'd like to do one of each kind of, but you don't have to if you don't want to. 15b, read it. of 1 over something. Like that. Okay. So my first thought is I want to rewrite this puppy. And I got the advice to always take ln and rewrite it as log base e, and I think that's really good advice. Next, if I can rewrite this thing now so that this right here is an e to a power, it'll make my life a lot better. Man, I feel like I'm going to catch typhoid in here. Everybody's coughing. Stop that! You know, you can't control it, but holy smokes. Can you imagine how paranoid you'd be if it was like Ebola land, or where everybody's getting something you can die from? Ugh. Here it's just like you can't get this cold or something. Alright, so, do you guys remember at the start of the year, it was like we really didn't know what was going to happen. Well, with Ebola, it was like people had come to the United States and gotten Ebola, and then people caught Ebola from the people who were in the hospital, and like it looked like it was just going to go crazy. It's pretty, well, it's contained here for sure. For a while, we couldn't even say that. But one country has completely shut, like they've celebrated the end of the outbreak, one of the major countries. But I think there's still 2 countries left that have a few, but it's gone down a lot. And it makes sense. When it first breaks out, there is a small chance that it's going to be like the big nasty one. Because there have been a few. Like the one that killed off, what % of the world population? I don't know. The plague. I don't know. It's massive parts of certain populations anyway. But the next big one, my prediction, is going to be bird flu. The bird flu, it already exists. The question is if it mutates enough to transfer from human to human, because it's deadly, like kills people. And we've had a ton of cases in Minnesota, for instance, where, but it has not been human to human. It's been like bird to bird. So if that stuff mutated enough to become infectious for humans, we'd have some trouble. All right, didn't need all of that, but since you're all still coughing and sneezing, I wanted to say something, acknowledge it. All right, this could be rewritten now. Here's the tricky part. E, and always these are fraction exponents, because see, look, it's a fraction. How did it become a fraction? Because of a negative power. How did it have a square root? Because of a fraction power where it's a root on the bottom. That's a square root, so there's a 2 on the bottom. And the last thing is that e somehow has to be put to the 7th, and therefore that's where the normal power goes. This is where the root goes, and that is where the negative comes in because you've got a fraction like 1 over. Now, once written like that, it's easy because this is the answer. If this and this are the same, the answer is the exponent. All right. Next question, yes. Okay, the roots go on the bottom. Do you get this 7 here is not what root it is. That is an e to the regular 7th power. This little 2 right here, that's the root. And I know there's no 2 in your problem, but it's got a square root sign, right? And that means a root of 2, a square root. So the roots go on the bottom. So if it's like this, it means that you want the square root and then to the 7th, and then the negative means you want it flipped. So one more like that real quick. What if it had been this? Like that. You would say, I want this to be 7, and it's got to be a fraction power and probably negative. That 1 over, does that tell you it's negative? Negative. This is an even, no, it's an odd root. Root go in the bottom. And then this 7 to turn into a 49 needs to be squared. That's another example like that. All right, any others you want to ask about? Any others on that page? That is the page we most recently did, so it's probably freshest in your mind, but if you're stuck on one now, ask now. All right, I'd like to do one condensing. Could you read me 22A, please? Because just for the benefit of the people that are at home today, 22A from the packet is? Okay. Now, condensing means that you take multiple logs, like a log and another log and another log, and I push them all down into one log. Condense it down. So this, and this can be all written all together as a log base 5. And if they are added, then they turn into a multiply. So it becomes that times that times that. I'm going to write it as 2 times 3 times 4. And then to simplify it down, log base 5 of 2 to 3 to 6 times 4 is 24. That is a typical condensed problem. You get it down to one log. A common mistake is you'll think that you should have like 2 logs in your answer. You can always get it down to a single log on the condensing problems we give you. Of course, there's also expanding. If you flip the page to the back side and read me one expanding problem, pick one that you would like help with on expanding. So, tell me that one. Come on. You want to do I? That's what the other class asked for. You're not alone, okay? Would you read me I briefly? Anybody? Letter I. Backside, letter I. Okay. ln. Okay. So expanding goes like this. It's a divide right now, divided by all that, so I'm going to change that to a minus. ln 3x minus ln, remember we're trying to make it bigger, so we have 2 ln's now. And we have 2x squared times y to the third. There, I made it a little bit bigger. All I did was handle that divide, turns it into a subtract. See this multiply right here? You can turn that into an add. So this will split up into 2 parts. ln of 3 plus ln of x minus still comes down here. And then this can be split up into a whole bunch of things. And the key there is that the powers, you remember how they come down in front? So that 2 can come down in front and say 2 ln of 2x. Okay. And, yeah, and then plus, because we have a multiply there, this 3 will come down in front of its log and be 3 log of y. And it's still not done because I have to break this up. And that can break up into a 2 plus an ln 2 plus an ln x. And that 2 is distributed to both of them. Oh, it should be ln. Thanks for catching that. It should be ln right. So again, it's not done. It's close though. But that part that I circled in red is the part you get to finish up. I think you can. I think you can. Sure you can. So this too, you're asking if that should be distributed to both of them, right? And I did, and that's okay. It is a very important point, and it's worthy of mentioning twice. Do you get that if I brought it up, it would actually be squared on this one and squared on that one? Like a tack cost. Okay. So anyway, so that 2 could be up on both of them. You see how each one gets a 2? Okay. So when we're done, it will have a 2 in front of both of them. Okay. So that's only a 14-minute recording, but I think it's probably enough to cover for what we need for today. And then if you want to ask more questions, of course, tomorrow is a Wednesday. It's a mass day. Those days are open for you to come in for me. And so therefore, you could come in the morning if you want to, tomorrow morning. And if I don't see you, I'll assume that means that you're either somewhere else or that you are feeling confident enough for this. I would like you to bring me your packets and show me how much you did. And if you only did a couple problems, but you're getting an A and you don't need to take it over again, I'll understand. But it is good review for the final. Final's coming. All the stuff's on the final. Yes? I am going to look at it and judge each person based on what they needed to do. I'm going to judge their effort. Yes, hold on just a second. That's all I have for the video for today.